Hello students, welcome back. In the last session we have discussed GUI programming in Python. In today's session also we will continue with GUI programming in Python. Today we will discuss geometry management. So geometry management, it simply means arranging components on the main window. So components on the main window can be arranged in a different way, and this arrangement is called a geometry management. As we have studied Java, we know in Java also we have different layouts or layout manager which organizes the components on the main container. So in Java we have layouts such as flow layout, which arranges the components in a sequential way one by one. We have a layout like a border layout which arranges the components in the corners like right, the top, bottom, or east and west corners. Same way, geometry management in Python can be used to arrange or organize components on the main container. So let's start with geometry management in Python. All tkinter widgets have access to specific geometry management methods which have the purpose of organizing widgets throughout the parent widget area or parent window area. tkinter exposes the following geometry manager classes. So we have the following geometry management manager classes in Python. These are pack, grid, and place, and all this belongs to tkinter library. So the classes are pack, grid, and place. The first, the pack. The pack class provides a method that is pack method. And pack method, this geometry manager organizes widgets in blocks before placing them in the parent widget. It is used to arrange the widgets in a block, or this particular method arranges the widgets in a sequential order one after the another, like the flow layout which is used in Java. Okay, then we have another, that is grid method. Again, grid method similar to Java's grid layout, and this geometry manager organizes widgets in table like structure in the parent widget. So we can arrange components in a table like structure, that is by using the row index and the column index. Then we have the method that is place method. This geometry manager organizes widgets by placing them in a specific position in the parent widget. Whenever we use a place method, we need to pass the coordinates there. We need to pass x and y coordinates to place our widget on the parent window. So we can place the widget manually at a particular location on the parent window by using place method. So let us look at these geometry management methods one by one. First, we will look at the tkinter pack layout. So pack layout, as we have studied, it is used to add the components in a sequential way. So you can see here one example is given. In this example, we have first imported tkinter. Import tkinter. If you look at this tkinter, you may find there is some difference between the earlier tkinter which we have used, and this difference is in the earlier case tkinter, T was capital, right? I'll show you the example which we have seen. Okay. Okay, look at this example which we have seen. Here tkinter, T was capital, but in this example you see T is small. This is because this is the issue with the version of Python which is used to create GUI application. If you're using a version that is 2.x version or 2.1, 2.3, whatever the earlier version of Python, then you have to always use T capital. So it is tk enter where T is capital if you are using T 2.x version, remember. When you are going for latest version which is 3.x, above the version 3, then the module name has been changed. It is tk in small. T is not capital in version 3.x, remember it. If you are using lower versions like 2.x, then you have to always use T as capital in tk enter, otherwise it will give you error. Okay, here this example it is done in 3.x version, and that is the reason T here it is small. Import tk enter as tk, even this is new here. In the earlier example we have used only import tk enter, but here we have added some more thing to it. We have said as tk, means we are creating another name for tk enter here, and another name for tk enter is tk. Okay, and why this is created? Because while calling tk or while even creating buttons, we need to use this tk enter. So it would be tk enter dot button, that will be too long. To make it short, we have renamed tk enter as tk. So instead of tk enter, we can use tk. Okay, so first import tk enter, then create a top level window. So here top level window is created, tk dot tk. Again this tk is the name which we have created, or you can say tk enter dot tk. Then we have added one more thing. So this is our top level window reference. Remember the name here we have given as app. Earlier it was top in the earlier example. Here it is app. App.geometry. This is the size of your top window, 300 pixels into 200 pixels. That is 300 by 200. It is the size of the top level window which we are creating. If you do not specify the size, by default it considers the size. Then we are creating a button here. Button w is equals to tk dot button, and we are passing certain parameters. The first parameter which is compulsory, that is the top level window object. Top level window object here it is app, and other parameters which we have specified, that is text and width. Width, that is the size of a button. Then if you look at, we are interested in this, the method pack. How we can use method pack? The object name dot pack, and to the pack you can pass optional parameter which is not compulsory, and this optional parameter says the name of the parameter is site, and the value which is specified here, it is left, which can be even right or top or bottom. So these values can be used. When you say value of the side is equals to left, the components are added from the left side. So it is added to the left side, remember. Then we have created one more button, tk button. You can see next button was created, and this button is added at the right side. Then we are entering the main loop, which simply displays our GUI, and when you execute this program you will get output like this. We have created two buttons, one is added to the left and another is added to the right, but these are in line, in sequence, remember. One is added to the left and another to the right. Okay, let us see this in our example. So this is our example where we have created a button. Here we did not specify the attribute side. I'll specify it now. Side is equals to, I'll say instead of left, I'll say right. Now if I execute, let us look at the output. Okay, now you can see the output here. So the button is added and it is aligned to the right because we have specified side is equals to right. If I make side is equals to left instead, it is added to the left. Okay, I have made it left now. Let us execute. Okay, look at the output here. The button is added to the left. Okay, so we can specify the side, which can be left, right, top or bottom. Okay, we have one more example over here where we have added 3 buttons actually, where one button is added to the left and other 2 are added to the right. Now you can see here the program is almost same, but instead of 2 buttons, 3 buttons have been added. So again, import TK, create a top level window, geometry, then the first button is created in the same way, but pack method includes side as left. Second button is created, text here it is east 1, and pack method includes side as right. So east 1 is added to the right, whereas west was added to the left. Then one more button is created, east 2, and again the side includes the value as right, and that button will be added to the right of earlier button which is already added to the right. There is one button which is already to the right, and if you add one more button to the right, it will be added to the right of the earlier button which was added. Okay, so this is how we can use pack layout to add components on the container or widgets on the container. Okay, there are other parameters which can be used with pack layout. The other parameters, TK enter pack to add widget internal and external padding. We can add padding to the components internally or externally by passing some other parameters as argument to pack method. In some cases, you need to add some padding inside or outside the widgets so that there is less congestion between the widgets and also between the widgets text and widget boundaries. Now you need two options as iPadX means internal padding in the X direction, that is horizontal padding. iPadY again internal padding, the padding between the internal boundary of the widget and its text, that is in the Y direction, that is vertically. Then we have padX and padY, that is the external padding outside the button and the main container. Okay, one example is given here. We can include iPadX or padX like this. Let me show you this with an example itself. Okay, this is our program, right? We have seen, and we have added one button to the left. Okay, let me execute it one more time. And you can see here, they have added a button and it is to the left, and there is no space between the left boundary of our top window, that is parent window, and the button. Suppose if you want some space between the parent window's boundary and your button, what you can do is, so we can add the parameter here, that is padX. We want horizontal space there, so the parameter which we need to add here, it is padX, and this is the space between the outer boundary of the parent window and the widget, that is button. That is the reason we have used padX, not iPadX, remember. So say I want some space that is 10. Okay, let us save it and let me check the output. Now you can see there is some space between the boundary and the button, and this is because we have added the parameter there. The parameter is padX, and this is horizontal space. There is no space added vertically because vertically we already have some space. Okay, so padx can be used for that purpose when you want external padding, external space between the widget and the outer the other parent control. Okay, similar way you can use ipadx to have space between the content and the inner boundaries of the widget. Like in this case we have hello here and we have inner boundary of the button, and if you want to increase that space we can use ipadx or ipad y. Let me show you here. ipadx is equals to say 20 and save it. I'll execute it. Now you can see there is more space between hello and the left and right side of your button, because we have added ipad x. X means horizontal. If you would have added ipad y, then vertically the space would have increased. Okay, so that is widget internal and external padding. Even TK-Enter pack layout feeling in x and y direction. You can feel the widget vertically or horizontally by using feeling, feel parameter. Now the following code, here it is, implementation, could automatically feel the widget dimension to the same width or the same height as window. If you want your widget to include complete space horizontally or vertically, then you can use a parameter that is feel. Now you can see here the pack method uses one parameter that is feel is equals to x, where the parameter will take complete horizontal space if it is x. X means horizontal space. Let me show you again. Now this button is not taking complete horizontal space, it is taking only little space horizontally. If you want it to take complete horizontal space, then what you have to do is in the pack method, so this is a pack method, so side you do not need to specify, you should not specify the side, you have to directly specify feel is equals to x. Okay, so save it and let us execute and check out the output. Now you can see it is taking complete space, horizontal space of the main window. So that is feel. Okay, same way you can even feel the widget vertically as well. Okay, that is about pack layout or pack method. Now the next it is grid layout or grid method. If you look at grid layout or grid method, as I have said, grid layout it is used to add components in a table like structure where we need to specify x row and column while adding the widgets. So TK-Enter grid is another and also the most important layout geometry method. Places widgets based on the position coordinates of the grid. That is, we have to specify rows and column where exactly we have to place our widgets. Okay, one example here, we are importing TK-Enter, then we have created a top level window, then we have created a label first, tk.label, by passing some parameters to it, and how the label is added. This is the name of the label dot. Here instead of pack we have used grid, and look at the parameters. We have specified column 0, means this label with the name label width needs to be added at column 0 and row 0. So suppose if this is our main window, the grid layout arranges it or considers the main window in terms of rows and columns, and the rows and columns creates cells, and these cells have the index values associated with, that is row index and column index. And if you want to add any component in the cells, you need to specify its index value, and that is what we have specified here. in the first component. Grid, we have specified column index as 0, means 0th column. So this is our 0th column, remember, and this is first column, like that, and this is 0th row. So 0th column, 0th row, we have to add this label width component, and we have also specified iPad X, pad Y, these things which we have studied earlier. And we have also used here one more parameter, that is sticky. Sticky parameter is equals to tk.w plus tk.n. W here west and here represents north. So what is that sticky? We will study. But right now just concentrate on this column 0 and row 0. When you add this label with a name label width, look at the output here. So label is added like this. It is at 0th row, 0th column, remember. Then we have created one more label, label height, in the same way. How this label height is added? So we need label height here. You can see the output label height. The text here, it is height ratio. That needs to be added here. So how the location is specified? Again, the column remains same, that is 0, means both are in the same column, you can see. Whereas row, it is 1, means it has to be below the earlier label. That is the reason row is 1. And again, iPad X, pad wise, the distance, and sticky has been specified. Okay. So we have added 2 labels. In a similar way, 2 entries have also been created. We have studied about entry widget, which is used to create single line. To enter single line of text, we can use entry widget. So entry is created by specifying some parameters. 2 entries are created, entry width and entry height, and they are again added. How it is added? First entry is added at column 1. Earlier it was column 0, remember. So it is added at column 1. So this particular entry, it is added at column 1 and row 0. And this is row index, this is column. Then column 1, then the next entry is added at column 1, again at the same column 1, but the row index is 1. So by using row and column index, we can add the widgets on the container or top level window when we use grid layout or grid method. Okay, so this is how we can add the components by using grid layout, grid method. Okay, now let us look at the sticky parameter which is used. So tk enter grid sticky options. Sticky determines how the widget sticks to the cell when the widget is smaller than the cell. Now consider this. Suppose, so this is our parent window, and the parent window, in as per the grid layout, it is divided into rows and columns. So say this is my rows and columns, and I have added a button at this position here. So this is my button. Now what sticky does is, if you want your button to be on the left side, or it is attached to the left boundary, you can use sticky option and you can pass the parameter that is west. When you say west parameter, it is attached to the west boundary of the cell. If you want it to be top left, means to the west, and to the top, means you have to pass both, that is west plus north, that is n. So that will be added your component, it is sticked to the top as well as left, that is west and north side. Same way, if you want to add your component to the bottom and left, then it has to be west plus south, west plus south, means it will be added somewhere here in a cell. So it sticks to the west and south location. If you want the component to be at the center in the cell, then you have to specify all the sticky option, that is west, east, north and south. Okay, this table shows you. If it is sticky is W, that means stick to left. If it is east, stick to right. If it is north, stick to top, and if it is south, stick to bottom. And the default sticky option is center, that is W plus E plus N plus S. So that is center. Okay, this is about sticky option. Okay, the next method is the place method or the place layout. The place method places the widget in an absolute or relative position in the window. For example, if you have a label created and if you use label a dot place, now instead of pack or grid, now we have used a method that is place, and we need to pass here two important parameters, that is the x coordinate and the y coordinate. Where exactly you want to place your widget, that needs to be specified in terms of x and y. Suppose this is our top level window, and if I want to place a button over here on the top level window, I need to specify the x value, so the distance from the left boundary and also distance from the top, that is x and y coordinate. So this is my y axis and this is the x axis. Okay, and this is my top left, and again the coordinate system always considered from the top left side, which is from here, which is 0. From here we need to calculate x and y, and that needs to be passed as an argument for x and y here. So like this, in case of the first label, we have placed it at 0 0, means it will be placed at a location 0 0. Same way at 20 20. So you can place a component at any place or any position in the top level window by using place method. Okay, place relative position. Even place method can be used to place a widget relative to the window, the main window. Now how it can be done? Place layout method also has a relative position option, that is, you can see here, if you want to place a label, label d dot place, instead of x we have to pass real x, that is relative x is equals to 0.5 and relative y is equals to 0.5. 0.5, it is the total. If you consider it as 1, then 0.5 means half of it. Remember, when real x and real y are in the range of 0.0 to 1.0, so the complete screen width or top level window width, it is considered as 1.0. So that is the complete top level width and height. Okay, it is the relative percentage of the widget position to the window size. Now for example, if I specify real x is equals to 0.5 and real y is equals to 0.5, means the widget is placed in the 50% of the window width and 50% of the window height. Means total window size it will consider, and as per that the widget is placed in the 50% of window width and 50% of window height. So relatively a widget can be placed by using place method. The parameters which you need to pass here, it is real x and real y. Okay, this is about geometry management in Python. So we will stop here today. We have studied three important geometry management method. One is pack, another is grid, and place method. We'll stop here. Thank you.